For inside this tutorial, we go to discuss about stack. So wetin come be stack? Stack na another type of data structure wey be say the data wey dey inside am dey always dey on top of each other. Very straightforward, very direct, and very easy. Say for example now, make I first write my stack here. Say for example now, we get a particular container here like this, right? And the data wey dey inside this container, the way wey we dey take structure the data, the way wey we dey take keep and arrange the data inside this stack, be say the data must always dey on top of each other. Like this. So if I call this one data 1, and I call this one data 2, and I call this one data 3. Shall you see this diagram where I draw out so like this? Now the diagram, the diagrammatic representation of stack be this. Now, the implementation of stack, they always follow a particular standard and principle of wetin we dey call LIFO. LIFO na just a simple way of how stack take dey work. So stack dey work with the principle of last in, first out. Wetin this one mean be say na the last element wey we add inside our stack na im go be the first element wey go come out. This one mean say you see this D3, say na im be the last element wey we add inside our container, inside this our stack container. If you wan come begin dey perform removal operation, there is no way wey be say we go fit just come inside this stack come remove this first element. The only way wey we fit remove any element for inside our stack be say we gats remove the topmost one wey be the last element wey dey inside our stack. Then we go remove the next one. Then we go continue like that until we finish the removal of the elements or the data wey dey inside our stack. That one mean say na the last element wey come inside our stack go be the first element wey go come out. Very simple, very straightforward, and very direct. Now, before we come continue to talk about different methods or different operations wey we fit dey perform inside our stack, remember say I tell you say the beauty of data structure be say we dey perform operations on them. Before we go fit perform operation on our stack, we gats understand say stack also dey work on the idea of indexing. So indexing na just the default way of counting inside programming, and it dey always start from a 0. That one mean say if we wan count the element wey dey inside our stack now, this D1 go be index 0, this D2 go be index 1, and this D3 go be index 2. Very simple, very straightforward, and very direct. So now, wetin come be the different operations wey we fit perform on our stack? This operation wey we fit perform on our stack na wetin dem dey call method. Now, wetin come be the different operations wey we fit perform on our stack? One, we fit perform push operation. Shey you see this push so, na just the name wey dem give the operation to take add element or data inside stack. So anytime wey you wan put another data inside your stack, na this push operation you go use. So push operation dey give us the flexibility, the authority to add data inside our stack. We get 2, pop operation. Pop na just a way, pop na the operation wey we dey use dey remove element or data from inside our stack. Another operation wey we get now is empty. You can tell the meaning of this is empty by the name itself. Say na the operation wey we dey use dey check whether the stack, whether that container is really empty, whether or not there is data inside our container. Another operation wey we fit perform na is full. This is full na just the operation wey we dey use dey check whether our stack don dey filled up. Another operation wey we fit perform na peak. This peak na wetin we dey use take check the topmost element for inside our stack. Say if we perform peak operation now on this stack wey I draw out so like this, we gats get this D3. Say na peak we dey use dey check the topmost element wey dey inside our stack. No be all of the methods wey dey peculiar to stack be this o. We get many other methods wey dey inside stack, and I go do my best to explain everything, to program out everything when we come switch to our IDE. But for this point, just know say stack na a container wey be say the data wey dey inside am dey always dey on top of each other. And stack dey always follow the principle of LIFO, last in, first out. That one mean say the last element where you put inside the container, now it go be the first element where you go fit comot. And the first element where you put inside the container, now it go be the last element where go comot. And we get different operations where they call methods where we fit perform on stack. We get push, we get pop, we get is empty, is full, pick, and many other methods like that. I guarantee you that at the end of this tutorial, it go dey possible for you to build your own stack and build your own preferred method. So wetin we go just do now be say we go just switch into our IDE, come program out all of these things wey we don diagrammatically represent for inside Java. So guys, maybe just quickly get started. Wetin we go do now be say everything wey dey this my right hand side, so wey we don conceptually structure out using pen and paper, right? We go come write am out for inside Java. Wetin I go do now be say I go just come to my data structure and algorithm folder wey dey here. Make I just expand am a little, right? So inside the SRC folder, then inside this default package, I go right click and choose new class. So I go just call this one stack tutorial. This stack tutorial where I call am, so you say if you call am anything where you like, that one no be issue whatsoever. Shey you get. So I go just hit finish here. But before we continue, I go quickly like explain something. Say you get three particular things where we guys put for mind in the implementation of our stack. The first thing we say we guys implement the container where we want add our data inside them. Shey you get. The second thing we say we guys implement all these methods, all these operations, push, pop, is empty, pick, right? We guys implement them. Another thing we say we guys implement how we want to take run our stack. So this first file where I call stack tutorial. Now inside this first file we go implement our container and our operation, right? Then we go just create another container where we go use implement how our stack will take run. So I will just come here again, right click, touch it, class, then I will just call this one stack runner. Stack runner. So this name itself fit be anything, or you fit call them anything whatsoever, that one no be issue. Then for our stack runner, I go just check this public static void main with the here. So I go just click check, then I go hit finish. Now this one self don't open for us. You go see say as this one take open, it get plenty things inside and pass this stack tutorial. This one just get 2 lines of code, right? But this one get this public static void main inside that. So this public static void main wey dey inside and it be the engine wey go make our stack to work, right? So I will just come back inside this stack tutorial now, come implement firstly the container where our data go dey inside. So how will they take implement container? We say we go use the principle of dynamic array take implement this container. Now if you no understand wetin be dynamic array, I go drop the link to my video where I explain everything where you need to know about array, right? So we go just proceed to implement our dynamic array now. So to implement our dynamic array now, what we go do, we go just talk say int, then we go open and close this angle bracket. After the opening and closure of this angle bracket, we go just give this container its own name, right? So the name we are going to give this container na bucket. Again, this bucket where I talk so like this, if it be anything, what it mean be saying na just the name of the container where our data go dey inside, right? So after I don't talk say buckets now, I go just talk say equal to new int. Then I go open and close this angle bracket again. So this angle bracket where dey last where I open so like this, we just get a way to tell our computer wetin the total size of this container wey we create go be. For example, now say this bucket go fit contain just 10 elements, or it go fit contain just 5 elements. Any number of size where you want your own container to contain. So for inside this tutorial, we just talk say make our container contain just 10 data. So I will come to the end of this line 4 program, come put my semicolon. So this line 4 code where I write so like this, that one means say we don't already declare our container. So now be this big rectangular container where I draw out. So the next thing where we guys do, we say we guys implement all these methods. So the first one where we go do now, we say we go just implement this push where we say now addition of data inside this bucket. So to implement that one now, we go just create our method with the push method. So to implement push method now, we just talk say public void push, right? So this push now it will be the operation, now it be the addition operation where we want to do. So because we don't want to put empty information inside our bucket, right? Our bucket must always contain data, right? So immediately we just say push, so we go open and close this parenthesis. Now inside this parenthesis, so because now the type of data we go there inside this bucket now integer data, right? So anything where we want push inside this bucket so must be integer, must be numbers, right? So I will just come inside that open and close parenthesis, then I will just say int data. So as I thought say int data now, I will come to the end of that open and close parenthesis, then I go open and close another angle bracket. So this angle bracket where I open, so now it go be now inside them we go come write all the logic we go make this our push method to work, right? So before we continue, I will quickly like bring your attention to something, will be the principle of indexing. Now, you see all this data where they inside this container, so right? You know, say I tell you, say the first element will go enter inside this data, go dey position 1, maybe index 0, right? The second one go dey index 1, maybe position 2. The third one go dey index 2, maybe position 3. So that one means say anytime where we want begin they add information inside our bucket, inside our container, right? We just instruct computer which position they go dey. And I already tell you, say the principle where stack to the operate, we say then they always dey the data where they dey inside them, they always dey on top of each other, right? So the first element will go enter inside this bucket, go dey index 0, right? The second element go dey index 1. So like that, they go dey on top of each other like that. Sure you get. So that one means say we guys be able to implement within this index be. So what I go do now is I go just come here, right? I go just say int index equal to 0. So this index variable where I declare so like this, now we go use take perform our operation inside this push method or push operation. So what I go do now be say one thing where I would like call your attention to be say before we begin add information inside our bucket, obviously we guys call that bucket, right? So that one means say we could just talk say bucket, right? So as I talk say bucket now, then I go use this angle bracket, talk say inside of this bucket, I want to make you have index inside that. So what did this one mean? We say this just very brief line of code. We say we just say go inside this bucket at this particular index, right? Then we will just say equal to data. So this line 8 program where I write, we say I just talk say okay, go inside this bucket at this particular index and assign any number where they come from push, right, into the bucket of this index, right? And you remember say at the start of our program, our index now is 0, right? So when we perform push operation here, right, push go inside our bucket, take add this data inside this bucket at this particular index. And because say index they start from 0, you go add this data at index 0, right? Now, one key thing where I would like to tell you, say, you know, say when we add elements inside our container, right, at index 0, if you want to perform another push operation, you no go dey that index 0 again. You suppose dey index 1. If you want to perform another operation, you suppose dey index 2, and like that. So that say then they dey on top of each other. So that the principle be that. So because say if you perform this first push operation, right? If you want to perform another push operation, that one means say our index go still be 0. So we just find a way to increment our index after the performance of each push operation. After we add any element inside our container, we guys be able to increment our index. So how we go take achieve this one? We go just come here to say index plus. So this line of code go increment index by 1. Sure you get. So when we want to perform another operation, index don't turn 1 already. Sure you get. So when we perform another push operation, so instead of push to come add our data inside index 0, no, you no go add them inside index 0 because index don't become 1. So you go come add them inside index 1. So that one means say you go dey on top of index 0. So when we perform the second operation, this line of code self go execute. So index go become 2. So you get like that. Any number of operation where you perform, you go always increment index because say now index we dey use they assign the position where our data go dey inside our container or inside our bucket in this example. Sure you get. So what I go do now be say I go just go test out this our code, right, for inside Stack Runner. So if I come to Stack Runner now, we just get a way, right, to link this Stack tutorial and this Stack Runner files together. So the way where we dey take link files together now, I say we dey create an object of this file. So we just create an object of this Stack tutorial class inside this Stack Runner. So what the object mean? Object just means saying like a copy. So we want to have a copy of this file, right, of everything we do inside this file, inside this Stack Runner file. So the way where we go take have that copy, we say we go just call the name of this class, maybe Stack Tutorial, right? We go talk say Stack Tutorial. So as I talk say Stack Tutorial now, then I will give them the name of that copy, right? Then I will just talk say my stack is equal to new Stack Tutorial. Then I go open and close this parenthesis. I can close my program. So what did this line 6 code they do exactly? They say it just they create a copy of everything where they inside this file, inside this Stack Tutorial file, inside this stack runner file, and that copy we dey call am my stack. So when we talk in my stack, we dey refer to everything wey dey inside of here. Shey you get? So we just create an object of stack tutorial or an instance of stack tutorial, but in a layman language, we just create a copy of that file inside another file wey be stack runner file. Shey you get? So as we create a copy of that file, so we fit no come use this my stack come perform all of the operation. You know, say this one na operation wey dey here, right? So we fit use this copy, wey be my stack copy, take perform all those operations. So we go just come here talk say, if you want perform push operation, now we go just talk say my stack, right, dot push. So you see, say when I write p, you don't bring out that file, that method wey be say na the operation wey we declare, right? Now we just hit enter here. Now e dey talk say make I add data where I want push inside this stack, right? So I go just talk say I want push 30 inside that. So you get. So I will run this program now. If everything works fine, we no suppose get any error for inside our code. So I will just hit this runner button here. Then where is this thing? Where is it running? If I hit this runner button again, I can't see it running. Hold on. Okay. So this is my console. I will just minimize again like this. Yeah. So this is my console. My console don't run it before. Right. So I will just run this code again. Right. You see, say nothing happened for inside our stack. Right. Because say when we declare this our push method, we just they add elements inside our stack. We know they do another operation. So we know they see, we know if you just see anything inside this our console, right? The next thing we are going to quickly do is say we just get a way to take show all the elements will be inside our stack, right? So we guys perform show operation. Okay, I don't get show operation for here. Well, that's fine. So we guys get a way to take show our operation. Show you get. So what I could just do now is I could just come here and say public void show, right? And come to the end of my program. Then I could just say this angle bracket. Now inside this our angle bracket, we guys perform the logic. Where we say when we run that logic on this my stack instance, right? It will show us all the elements we dey inside that. Show you get. So I will just come back here. Come talk, okay. When we want to show, if we want to show all the elements we dey inside our stack, right? We guys get a way to take travel inside this container to go one after the other inside this container. Come print out all the elements we dey inside that. So to take show all the data we dey inside this bucket container, right? We go just use the principle of for loop. So I will just talk say for. So as I talk say for now, we just talk say for int I in this case now the each element will be inside that bucket. So I will just say for int I in bucket, right? Then I will just open and close this my angle curly parenthesis now, right? I will just say system dot out dot print, right? Then I will print I. There you get. So make I first quickly run over this over the explanation of this code again. So I talk say public void show, because we dey show element, we know they add element inside this data, inside this bucket, right? So we don't go accept any parameter here, right? Then I will just say, talk okay, for int I in bucket, for every element inside this inside our stack, inside our container, right? Print out all the elements. Very straightforward, very easy and simple. Sure you get. So I will just come back inside our stack runner now. Then when we add element, right? We want to show the element where we don't add. Sure you get. So I will just come here talk say my stack dot show. If I talk say show like this, you say we don't get this show operation. So if I run this code again like this, you see say we get 300000000. So there is a little bug inside our code. What we go do is say come back inside our stack. Instead of using print, we will just use print line. Sure you get. So we want every element to be on top of each other, so that one self go dey very logical to our site. So I will just come back inside my stack runner code now, come press this runner button. Now sure you see say we don't get 30. So we get 00000 because by default the element will dey inside our stack now 0. If we never add elements inside them, the default element will go dey inside them now 0. That one make more human sense. Sure you get. So before we come begin to perform this pop operation, right? We go come perform we go add as many elements as possible inside our stack. Right? Come here again, make I just paste this thing. I go call this one 90. I will come here again, Control V, Control V, Control V. So I will just call this one 2. I will call this one 300. I will call this one 20. Right. So I don't add how many elements now? 1, 2, 3, 4, 5. So I don't add 5 elements inside our stack. Will be my stack here. So we won't show all the elements where they inside our stack. So I will just come here again, run this runner button. Now, you see, we get 30, we get 90, we get 2, we get 300, and we get 20. Now I will just come here and say, okay, my stack dot pop. So as I talk, say my stack dot pop now, you see, say this thing will carry error come. The reason they say we never implement our pop operation. Sure you get. So what we go do now, we say we go just go quickly implement this pop operation. So I will just come back inside this stack tutorial. Now we will just come here again. Make I just put spaces between these codes so that it will just make complete sense. So this one our push, this one our show. Then we want to increment. Then we want to implement our pop. So I will just talk say public void pop. So as I talk say pop now, then I will just open and close this my parentheses. Then I will just then I will come here again, talk say open and close this my curly parentheses. Now inside this my curly parentheses wey dey here, right? Now here I will come write all the logic we go make this our pop operation to work, right? So the logic we go make our pop operation to work, we say we go come employ the principle of index again. The first thing wey we guys do, we say we guys decrement our index. We will say index minus minus. Then we go inside our bucket, or say bucket, then bucket of this angle bracket index. Then we will just talk say and we will just talk say equal to a 0 here. So now maybe just quickly run our pop operation, right? We will just come here, talk say inside our stack runner, we will just perform this. We will just press this runner button. Now what you see here, no be the number, no be the data after we perform our pop operation. Now the data before we perform our pop operation, right? So what I will do is say instead of this show method to be at this line 13, I will just cut and come out, come put them after this pop operation. Sure you get. So what this one I mean we say we add elements, then we pop out the topmost elements, then we won't come show all the elements will remain. So if I run this code again, then you go see say we don't come out 20. So now we get 30, we get 90, we get 2, and we get 300. Sure you get. So now I mean say we don't remove this my stack. We don't use this pop. Remove the topmost element for inside our stack. So you go to see and say why they say na 20 you remove. Why they say you don't remove 30 because in a 30 day topmost here. Well, the way programming take the work, we say it work in order. Sure you get from top to bottom. Now how programming take the work with that. Forget how they take arrange them here. This one I just typing format. Sure you get. So when computer won't read this code, you go first add 30, right? Then you go come down again, add 90 and like that and like that. So when we come perform our pop operation, now we say 29 be the last element wey dey inside our stack, right? Because of the way they take work from top to bottom. So when we perform this pop operation, we go comot 20, come show us the remaining elements wey dey inside that. Sure you get. The next operation wey we wan perform now is empty. Sure you get. So wetin I go just do be say come back inside our stack tutorial, come perform our is empty operation. Then I will just come here again, talk to public void is empty, right? Then we go open and close this our parentheses, and at the end of that parenthesis, we go open and close our angle bracket. Now we want to say, so if no element dey inside our container, that one means say our container is empty. But if at least one element dey inside our container, we want print out false because that container no longer dey empty. So you get. How we want to check whether element dey inside this container? The way we go check whether element dey inside this container, we say we go use the concept of index. Take check whether elements dey inside our container, right? So if our index, index is equal to 0, that one means say if index is equal to 0, remember say the start of our program index now is 0, right? When we add elements inside that container, right, the element when we add inside them, we go come take the value of that index, then we go increment our index to be 1. Now immediately we add elements inside our container, index go become 1 instantly. Anytime where our index is 0, it means say we never add element inside our container, because say whenever we add element inside our container, index go always increment. So if index day is 0, it means say we never add element inside our container with that. Very simple, very straightforward and direct. So as I thought, say if index is equal to 0 like this, then I go open and close this my angle bracket. Then I go just talk say, okay, print system.out.println, system.out.println. Then I want print true. Print true. Right. It's here the system.out.println. Right. I want print true. Sure you get. So, but if index is not equal to 0, if the value of index is greater than 0, then we want print waiting. We want print false. Then we talk say else. Make I just copy this one. Control C, Control V. Else print false. Sure you get. So if you go back inside our runner file, so I could just come here to say my stack dot is empty, right? Now, if I run this program, then you see say it print false for us. Why it print false for us? We say our stack no dey empty. Sure you get. So if I just clear all this operation where we don't use add elements inside our stack, so say I clear them command, right? Make I clear this show method because we know they show anything, nothing there inside our stack. So if I just run my stack dot is empty, because nothing there inside our stack now, we supposed to say true, right? So I will just come here, run this program, then we say true. Say nothing there inside our stack. Sure you get. So I will just come back here again, press Ctrl Z, bring back all the functions where we don't implement on top this my stack. Sure you get. The next operation where we want to perform now, say our stack is full. Sure you get. So to take perform is full operation now, I will just come back inside this place. Then we will just come here to say, okay, the way we want to take perform is full operation, we say we want to check whether all the elements where they inside our bucket, right, it don't reach the size where we declare inside this our bucket. Remember, say the capacity of our bucket is now 10. Sure you get. So what we go just do now, we see we go just come back here. Here. Now I don't want to make you confuse this thing together because it almost confused me now too. So this one, as it like this, now one operation on you. This one another operation. This one here, now another operation, and this one here, now another operation. So individual operation, they inside the stack class. Sure you get. So I could just come back down. So now I could just talk say we want to implement our is full operation. Now I could just say public void is full, right? Then I go open and close this parentheses, and in front of that parentheses, I go open and close another angle bracket. Now this angle bracket where I open, so now inside them, the logic will go check whether our stack or our container don't they filled up or not. So I want to check whether something is full. To take check whether something is full now, we got to know the total size of that bucket, of that container. And here, the total size of our container is 10, but we not go just come here, come put that 10 here, basically. If you put 10 here, we they do hard coding, because we they use Ojoro method. Sure you get. But we don't want to do something like that. What we want to do exactly the same. We want to use if condition, take check whether our index is equal to our is equal to the size of this our bucket. If index is equal to the size of this bucket, that one means say our element don't they filled up, because at that point index could not become 10. Sure you get. Because 10 is equal to 10 now, therefore our container don't they filled up. Sure you get. So now I will just come here again, talk to if the value, if index is equal to bucket what am I typing? Is equal to bucket dot length, right? Then we want to say, okay, system dot out. Make I just come here, copy this one, Ctrl C, because I'm super lazy. System dot out dot print line. We want print true, because at this point the value of our index don't become 10 as the capacity of our bucket. Sure you get. Otherwise, we just talk to else. We go just talk to okay. Make it print false for us. Then I will just change this one to false. Right. So we will just come here again, run our program inside this stack runner. So I will just press run now. Oops, I never. Okay. Now we just talk say my stack dot is full, right? If my stack is full, right, then print true. If my stack is not full, then print false. Then okay, what I go do is I go just empty, comot this is empty operation. Then I go just run my stack. Now you tell me say false because say my stack is not filled up, right? Now I tell you say the total capacity of the element wey our stack fit contain na 10. How many elements we don implement here? 1, 2, 3, 4, 5. So now we wan come add another 5 elements, making 10. So I will duplicate this one like this. Make I call this one 200. I will call this one 900. I will call this one 12. I will call this one 3000. I will call this one 2000. Right. So I will come implement, I will come run this my code again to come check whether our container is full or not. But we know already that our container don't contain 10 elements now. So we suppose get true here. So I will just come here, run this program, then oops, we still get false. This program is not working. Okay. Okay, the reason why we dey get false be say immediately we add all these 10 elements, right? We come dey pop out the last element, we dey delete one element wey be the topmost element. That one mean say when we add 10 elements, we comot one, our total size, the total size of the element wey dey inside our container don turn back to 9. Shey you get? Now I go just come comot this pop operation, come rerun our program. Shey you see say we don get true here because the element wey dey inside our container don dey filled up, they don reach 10 already. Shey you get? So the next thing wey we go just perform na this pick operation. So now we go just come back inside our stack tutorial file, come here, come talk say public void pick, right? Then we go just come here, talk say okay, open and close our curly parenthesis. Then inside this our curly parenthesis now, we want talk say we wan perform similar logic wey we dey perform here. Shey you get? Then we go just come back here, Control C, copy this logic wey dey inside this pop operation, come back inside our pick, then Control V. The only difference wey dey inside this pop and pick be say we no dey delete element, we no dey set our elements to 0. Wetin we dey do be say we go just go inside our element, print out the value of the topmost element. Then we go just talk say okay, make I just give am variable int topmost, right, is equal to bucket bucket, is that bucket of index, right? You just talk say okay, if topmost is equal to bucket of index. So wetin this one mean be say as we dey, this one mean say the value of index after we don perform so many, whatever the value of index be, just store that variable inside topmost, right? Then we go just come back here, talk say we wan print out the value of topmost. Then we talk say system dot out dot print line, right? Then we wan print out topmost, right? So I will just end this program with my semicolon. So as I write this pick operation so like this, wetin we dey do be say now make I first explain why we dey use this index minus minus, right? So why we dey use this index minus minus be say the first time when we add elements, right? You know say the element go dey index is 0, right? But the value of index go increment to 1 to take accommodate the next element wey dey come. But that element wey we first add, so it go take the index is 0 at position 1. So this one wey dey here, this D1 na position 1 for index 0. This element e dey position 2 for index 1. So index na the way wey we dey use know the position where each element dey for inside our container, right? Now if we add the last element in this example go be wetin, index 2 but position 3. Just ignore position now, focus on index. Now index 2. So anytime wey we say we wan have access to this last element, right, we gats know the exact number of our index. And you know say when we add the last element inside this container, right, index go come become 3. So when we dey refer to index 3, right, we no dey point to this last element because this last element na index 2. The only reason why we get our index to be 3 be say it give us the opportunity to add another element if the size of our container fit container. Shey you get? So now wetin dey happen for here? Why we dey use this index minus minus? Say anytime we wan have access to the last element wey dey inside our bucket, we gats first decrement our index first, because say remember say when we add this 3, our index go jump up to 3, right? Meanwhile this element, we fit only get this element at index 2. So I know say indexing dey a little complicated to understand, especially for say we dey use them alongside position, right? But just know say this element, anytime wey we wan get access to element for inside container, na index we dey use. The first element wey dey inside our container na index 0, right? So this one wey be the last element wey dey inside our container, e go be wetin? E go be index 2, right? But because say when we perform push operation, our index go don increment to 1. So if we dey use index, right, we gats use index very carefully, right? That one means say if you wan get access to the last element wey dey inside our container, we gats remove 1 from index firstly before e go give us the value, before e go give us the correct index of the last element wey dey inside our container. Shey you get? Na why we dey get index minus minus here be that. If I come back inside my container, when we add this 2000, right, you know say this one na index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, index 9. So this value here na index 9 e dey. But when we add this value, our index don increment to 10, because we dey do index plus plus here, right? Because we dey do index plus plus here. So when we wan have access to, anytime we wan have access to this element wey dey position 10 or index 9, we gats decrement our index firstly, so that our index go become 9 again. Now wetin we dey do here? Simple logic. Now wetin we dey do here? Index minus minus. And na the same thing wey we dey do here too, to take have access to the last element wey dey inside our container. So when we get access to the last element wey dey inside our container, right, we wan come store that element inside topmost. Then we dey print out our topmost here. Shey you get? So if I come back inside this my stack runner, instead of showing all the elements, no, I no go show all the elements. I go just talk say, I go just come here to say I wan check the topmost element. I go just talk say my stack dot pick, right? So as I talk say my stack dot pick, so like this, I go end am with this semicolon. Then I go run my program. Now shey you see say e dey show us say 2000 na be the topmost element for inside our program, and my stack dot is full. That one sef dey show as true, because say this element don dey filled up. So if I comot just 1, so like this, okay, I no go just comot 1 manually. I go just remove 1, right? I go just talk say my stack dot pop, right? As I talk say my stack dot pop, so I go just press runner button. Then it go talk say false, because say I don comot 1 element inside my stack. Shey you get? Then as I comot 1 element inside my stack, you know say I talk say pop dey comot the topmost element inside our stack. So you go comot this 2000. So as you comot this 2000, so 3000 go be the topmost element. Now why we dey see 3000 here? So our stack dey work awesomely, it dey work perfectly. Shey you get? So as we say, we don talk about stack and implementation of stack, including different operations wey we fit perform inside our stack. Na so e go be for inside this tutorial. I go see you for the next tutorial.